Distance x of a particle moving in one dimension under the action of a constant force is related to time t by the equation t is equal to root x plus 3. Find the displacement of the particle when its velocity is 0. So how do we know the velocity is 0 unless we have an equation for velocity? Let's first find the equation for velocity from here. So we know that v is equal to dx by dt. So if x is in terms of t, we can do this dx by dt very easily. Here it is the case. So let's put this equation in a different form. Root x is equal to t minus 3, x is equal to t minus 3 whole square. Now replace x here. So v is equal to d by dt of t minus 3 whole square. This comes out to be 2 times t minus 3 is equal to 2t minus 6. So now we know that v is equal to 2t minus 6. So when velocity is 0, t is equal to 3. So find the displacement. So what is the x when t is equal to 3? So 3 is equal to root x plus 3. So x is equal to 0. So this is our answer. Displacement is 0 when velocity is 0. A car travels first half distance between two places with a speed of 40 km per hour and the second half with the speed of 60 km per hour. What is the average speed of the car? So let us say the distance between those 2 points is 2x, therefore this is x and x. So first half, this part the car covers with a speed of 40 km per hour and this part covers with 60 km per hour. Average speed is total distance upon total time. Total distance is here 2x. Total time is the sum of time it takes to travel this distance plus the time it takes to travel this distance. So if this is t1, if this is t2, t1 is distance upon time, x upon 40, t2 is x upon 60. So total time is equal to x by 40 plus x by 60 is equal to x by 24. So average speed is total distance upon total time, 2x upon x by 24. So x and x gets cancelled, this becomes 48. So units will be here kilometer per hour. Be careful about the units. Here everywhere we are taking kilometer per hour, so answer will also come out to be in kilometer per hour. An object moves from A to B with a speed of 40 meter per second and returns from B to A with a speed of 60 meter per second. Calculate average speed and average velocity of the object. So it moves from A to B in 40 meter per second speed and B to A in 60 meter per second. So average speed again is average distance upon average time. So again let's take this as x. So total distance is 2x upon total time, x by 40 plus x by 60. So this is like the same problem we did before, and if you solve this you will get it as 48 meter per second. Only the units are different. There it was kilometer per hour, here it is meter per second. This is your average speed. Calculate the average velocity of the object. So average velocity is equal to total displacement upon total time. Displacement is 0 here, so this comes out to be 0. A man walks on a straight road from his home to market 2.5 km away with a speed of 5 km per hour. So this is your home This is the market. It travels from home to market with a speed of 5 km per hour, and this distance is 2.5 km. Finding the market closed, he instantly turns and walks back with a speed of 7.5 km per hour. What is the magnitude of average velocity? Average velocity is 0 because he is returning home. Magnitude of average speed of the man. So here also average speed is equal to total distance, which is 2.5 plus 2.5, 5 upon total time. So while going it is 2.5 divided by 5 plus while coming 2.5 upon 7.5. So comes out to be 6 km per hour. What is the time taken while he is going here? It is 2.5 by 5, which is 1 by 2. So it actually, while going, it takes 30 minutes. While returning, it is 2.5 by 7.5, which is 1 by 3. So 1 by 3 of an hour is 20 minutes. Now for the second part, what is the average velocity and speed for the interval of time 0 to 30 minutes? So from 0 to 30 minutes. Average speed is same as average velocity because the displacement is same as distance, and it is equal to 2.5 divided by 5, it is given 5. So for 30 minutes, first 30 minutes, it is 5 km per hour. From 0 to 50 minutes, so it takes 30 minutes to going and 20 minutes to come back. So when it comes back to the home, your average speed again is 6 km per hour, and average velocity is 0. 0 to 40 minutes. So 30 minutes here and 10 minutes here somewhere. So it goes like this for 30 minutes, and for next 10 minutes it returns back. So totally take 20 minutes to return back. So in 10 minutes he will reach half the distance, which is 1.25 km. So to calculate average speed, we need total distance, which is 2.5 plus 1.25. Plus 1.25 divide by total time taken, 30 minutes, it's given 40 minutes. So here we need to convert minutes into hours, 40 by 60. So this is equal to 3.75 by 40 into 60, 5.6 km per hour. And average velocity. So here the displacement is this distance, which is 1.25. So average velocity is equal to 1.25. Time taken is again 40 by 60. This comes out to be, so basically 1/3 of this. So you can calculate this and you will get answer as 1.8 km per hour. So why I said 1/3 of this? I can numerically I can see that this is 1.25 and this is 3 times 1.25. So whatever average speed I get here, this average velocity will be 1/3 of it. So I can directly divide this by 3, or you can calculate this 1.25 into 6 by 4. So you'll get the same answer. A woman starts from her home at 9 a.m. walks with a speed of 5 km per hour on a straight road up to her office 2.5 km away, stays at the office till 5 p.m. and returns home by an auto which is of the speed 25 km per hour. Plot xt graph for our motion. This is on x-axis we always represent time, and then y-axis we represent x displacement. So he starts at 9 a.m. So let's say this is 9 a.m. and it walks with a speed of 5 km per hour. So its speed is 5, which is the slope of xt graph. So let's say it's like this. To reach her office, which is 2.5 km away. So this is 2.5, and with the speed of 5 km per hour, how long it will take to reach 2.5 kilometers away? It will be 30 minutes, half an hour, as your time is x upon velocity. X is 2.5, velocity is 5, so is equal to 1 by 2. So she will reach here in 9:30 a.m. half hour, which is 9:30 a.m. Then from 9:30 to 5 o'clock she is in her office, so displacement is now 0 from her not 0, it's stagnant, it is 2.5 km. So until 5 o'clock her displacement is 2.5 km, and returns home by an auto at a speed of 25 km per hour. So while returning back, the speed is much larger, so the slope will be much steeper. So this is, if this is theta 1 and this is theta 2, you can say tan theta 1 is the speed slope and it's the speed, it is 5 km per hour. Tan theta 2 is 25 km, 25. So here theta 2 is this obtuse angle, so it will be minus 25 because velocity is in negative direction. So if we are considering the direction of the office as positive, this is home, this is office, so we are considering this direction as positive. So while traveling from home to office, the slope is positive. While returning from office to home, the slope is negative. And the slope is much steeper because the velocity is more. Tan theta 2 is minus 25 actually. Now, how long it will take? So again, time is equal to your x upon v. X in this case is also same, 2.5 upon velocity, however, is 25. So it is 1 by 10. So 1 by 10 of an hour, which is around 6 minutes. So this will be 506. This is the curve, xt curve for the woman. So only two interesting things to note here is that this slope is less steeper than this slope. So here tan theta 1 is 2.5 upon 30 minutes, which is 1 by 2, which will give you 2.5 divided by 1 by 2, come out to be 5 km per hour, which is correct. And here the slope is steeper, so here this ratio will be 2.5 upon 10 minutes, which is 1 by 10, which gives you the slope is minus 25. So you should be able to draw something from the problem, and from the graph itself you should be able to know that what is happening. So this is the, like, she is traveling to the office with some speed, and while returning she is returning with higher speed. Initially displacement is 0, at the end also when she reaches home the displacement is 0, and finally during the interval from 9:30 to 5 she is at office, so your displacement is constant, and the slope of a constant of a fixed line, constant line, is 0. So its velocity is 0, velocity is positive, velocity is negative, and much more negative than it is in the positive side. A drunkard walking in a narrow lane takes 5 steps forward and 3 steps back. So it's traveling like this: 5 steps forward, then 3 steps back, then 5 steps forward, then 3 steps back, then 5 steps forward, then 3 steps back, and so on. Each step is 1 meter long, and requires 1 second. Plot xt graph for its motion. Determine graphically and otherwise how long the drunkard takes to fall in 13 meter away from start. So how long it takes him to travel? 13 meters from the start. So xt graph. It starts from 0, displacement is 0. Now the slope again will represent the velocity. What is the velocity? It takes 5 steps, that is 5 meters in 5 seconds, because each step is 1 meter long and requires 1 second. So its speed while going forward is 1 meter per second. From this itself you can say that the speed is 1 meter per second. Each step is 1 meter and requires 1 second, therefore speed is 1 meter per second. So 1 means the slope will be at 45 degree, tan 45 is 1. So it goes like this. So this is 5, until 5 meter it goes forward, and 5 seconds. Now after first 5 steps it falls back 3 steps. Again the velocity is 1 meter per second, but it's in negative direction. So slope is negative, but it is again at 45 degree. So it falls back, so 3 steps. So this is 2. Then again it will go up 5 steps. So 2 plus 5, this is 7. And again it will fall back 3 steps. So it will be somewhere 7 minus 3, which is 4, but no need to draw it. Then again it goes 5 steps. So you can see that this increment in the y-axis, it is happening in terms of 5, 7 and then 9, and like that. So after 9 it will be 11, and after 11 it will be 13. So how long the drunkard takes to fall from 13 meters from the start? So this is one cycle. After one cycle, so it takes 5 plus 3, 8 seconds for one cycle. So until it reaches the 11th until it reaches the 11 meters, how many cycles is covered? This is 5 plus 3, 8. So 8 plus 8 plus 8, 24. And let's include this cycle also. 24 plus 8, again 32. After 32, in the next 5 seconds, it actually reaches its 13. So until here, it takes 32 seconds, and then it so from here 11 it will fall down 3 steps and it will become 8. So this is the 8, and then next 5 steps it will reach its 8 plus 5, 13. So again it will be 5 more seconds to reach the 13 meter line. So this will become 32 plus 5 is equal to 37 seconds. A boy reached a railway station 4 km away from his house, running with a uniform speed in 1 hour. He took rest for 0.5 hours at station and then came back to his house walking with a uniform speed of 1.5 hour. Uniform speed in 1.5 hour. Represent the whole journey of the boy by a time displacement graph and determine his average speed. So this is displacement and time. So he reaches 4 km away, 4, and uniform speed in 1 hour. So speed is, for the first part, 4 divided by 1. which is 4 km per hour. So it will be like this. This will be 1. So slope again is the velocity. So it is 4 divided by 1. So it is 4 km per hour. So this is correct. After that, he took rest for 0.5 hours. So 0.5 hours will be somewhere here. So it is his displacement is constant for next up to 1.5 hour. Then came back to his house walking with a uniform speed in 1.5 hour. So after 1.5, he takes another 1.5 to come back. So this is same as this 1.5. So it is 3 hours total. So from here, it comes back to his house. So this is the whole journey of the boy, and determine his average speed. So average speed we can find from average total distance traveled upon total time taken. So in this case, total distance is 4 while going to the station plus 4 while coming back from the station divided by total time, which is 3. So is equal to 8 by 3 km per hour. Again, be careful about unit always. So be consistent with the units in the whole problem. We can also find this average this distance from this area under the curve. It is not simpler way, but it is another way of to find it. So it will be half sum of the opposite sides in a trapezium, which is 3 plus 1.5, 4.5 into height, which is 4. This comes out to be 9. Actually, no, we cannot do this. This area under the XT curve is actually meaningless. Only area under VT curve will give you the distance traveled. So this is the distance. This area gives us nothing. It's useless. So this is the only way. We know the total distance. Going up, it is 4, while coming down from the station, it is again 4. So total distance is 8 divided by total time, which is 3 hours. Total velocity, average velocity will be 0 because it is returning back to the home. A body starting from rest moves with an acceleration of 5 meter per second square. After 4 seconds from starting, the force accelerating the body is removed and there is no opposing force also. Draw time velocity graph for the first 8 seconds of the motion of the body and determine from the graph the distance traveled in 8 seconds. This is velocity and time. So starting from rest, that means at t is equal to 0, v is equal to 0. So we need to start our curve from here. So acceleration is 5. So acceleration is again curve of a VT graph. So it starts from here and let's say it is here. So this is theta, then tan theta is 5. After 4 seconds of starting, the force accelerating the body is removed. So after let's say 4 seconds, there is no acceleration, there is no force. So velocity should be constant. It's still positive, it's still going with some velocity, but it is now constant velocity. So after 4 seconds from starting, the force is removed, there's no opposing force. Draw time for the first 8 seconds. So up to 4 seconds it is like this. So for the next 4 seconds it will be like this. Determine from the graph the distance traveled in 8 seconds. So distance traveled here will be the area of this A, B, C, D. So distance is equal to area of A, B, C, D is equal to, this time we will do it, so here it makes sense, area of a VT curve, which gives us a distance. So half sum of the opposite parallel sides, 8 plus 4, 12 into height. So in this case, What is the height? So we don't need know the velocity right now, so we need to calculate this. So v is equal to u plus at, u is 0, so v is equal to acceleration is 5 meter per second square up to 4 seconds, so 20. This is actually 20, so half 12 into 20, so it is 6 into 2, 120 meters.